Alright, so you have keeper 4.2, experiments. Now this keeper is primarily talking about after we created our samples, after we found a good way to sample our population, now we want to do some sort of experiment. Now we have two ways of doing this. We can either do it using observation, just looking at what we want and making conclusions based off what we see, or we can actually literally do an experiment, which means that we are giving them some sort of treatment. We're doing some sort of, put it like this, we're actually doing something. We're doing something to see what the result will be, versus observational, we're just looking at it. So here again, we have the observational study observes the individuals and measures the variables, but we don't do anything to influence the responses. Versus an experiment, we deliberately do something. We deliberately impose some sort of treatment on the individual to measure their responses. So I'm purposefully giving you a drug to see how you react. That would be an experiment. Alright, so oftentimes we don't really like to use observational studies because what happens is a lot of times we have other outside variables that are affecting the study. These variables are called confounding when the two variables that you're looking at are associated in some way where we can't measure or we can't determine what their causes on what we're looking at. In other words, I might be doing a study on hours of sleep versus your grade in school. Well, if I'm doing an observational study and I'm just looking at it, I'm not saying you guys get 5 hours and you guys get 10 hours. I'm not doing that. I'm just looking at what you guys have. Well, there could be other things that are causing your grade to either increase or decrease. Maybe you had a great breakfast. Maybe you studied more. Maybe it has nothing to do with hours of sleep, but because I can't tell, because I didn't do an experiment, I have a confounding situation. And those variables that are causing that confounding is called lurking variables. They're variables that aren't necessarily part of the study, but they're somehow influencing the response of whatever we're looking at. So even though I'm not looking at whether or not you ate breakfast in the morning, your eating breakfast could have affected your grade in school. That makes sense. Alright, so ideally we want to do experiments. Again, we don't really want to do observational studies because we have all these lurking variables and they kind of jack up your results. You really don't know what to think. So if you do an experiment, you can actually control for some of those lurking variables out there. You can control for some of the things that could be messing up or jacking up your results. So the first thing we need to know is in an experiment we have, or we're giving a treatment. So a treatment is what we give. A treatment is what we give to either the person that we're doing the study on, or the animals or the objects, whatever we're giving the study on, we're giving them that treatment to see whether or not that treatment has an effect on them. Now the people, animals, or objects, or whatever that we give the treatment to, that's called our experimental unit. That's the smallest possible collection of individuals or subjects that the treatment is applied to. And basically we just observe to see what their response is. How do they react? What happened when we gave them this treatment? Another thing is just note that when we're dealing with human beings, we call the experimental units subjects. We don't call them like anything crazy. We don't call them experimental units. That sounds like we're trying to kill them or something. So we call them subjects. Alright, so ideally what you want to do in an experiment is you want to use random assignment. Random assignment basically says, okay, you have different groups of people, one group that's going to get a treatment and one group that doesn't get a treatment. Well, we're going to randomly assign you to the group and we're going to randomly assign what treatment you get. That's random assignment. Now, if we want to completely randomize our design, we'll start with our experimental units. We'll do our random assignment to put them into group 1 or group 2. From there we'll give, treatment 1, treatment 2. Again, that's randomly chosen which group got it, and then you compare the results between the two groups. Now be mindful that some experiments, or most experiments, a lot of good experiments also have a control group, and a control group is basically the group that gets absolutely nothing. So coming off from like here, I would have like group 3, and that would be my control group. They wouldn't get a treatment. They're not getting treatment 1, they're not getting treatment 2, they're getting absolutely nothing. So I can see basically what it should look like with no treatment at all. All right, and a lot of times that helps to eliminate some of those lurking variables in confounding situations. All right, so basically your principles for your experimental design, you want to make sure you're controlling for lurking variables. Again, a lot of times that control group will help with that. You want to make sure you're using random assignments so that you're not putting in your own personal judgment by placing people in groups that you want them to be in. You're using random assignment to eliminate some of the bias, and also some of the lurking variables that could have arose from you assigning them to groups. So again, you want to use random assignment. And then you want to use replication, which just means that you're using enough experimental units so that you can actually see the differences, and you can tell the differences between the two groups. You want to make sure your sample size is large enough. All right, so what can go wrong? Well, there's a lot of things that can go wrong with the study. The first thing we need to understand is that sometimes we have something called a placebo effect, and that placebo effect is basically where it's kind of like a mental thing. Like you give a group some kind of treatment, but the treatment really isn't doing what they think they're doing. So for instance, I'm going to tell you that I'm going to give you aspirin, and I want to see how quickly your headache goes away. And I give it to you, you're like, oh my God, my headache went away. But truth be told, I gave you like a water pill or something like that. So that's the placebo effect, where you think that something's happening, you think that something's changing in your body or whatever based off of the experiment or based off of the treatment, but really nothing's happening. So that's your placebo effect. You start getting results, you're becoming healed, or you feel better or whatever, because you think that you're receiving some type of treatment. So therefore, because of that, whenever possible, you want to make sure you try to do what we call a double-blind experiment, where nobody knows. The subjects don't know. The people who's actually giving the medicine, they don't know. No one knows except for the researcher who's getting what. So I don't, like, if I'm the person that's giving, say I'm doing an experiment where I'm giving you medicine, aspirin, I have aspirin in a container. I don't know if you're getting the aspirin, or if I don't know if you're getting the dummy pill. I don't know, and you don't know. So that's a double-blind experiment. Now, if you were the only one that didn't know, then that would be a single-blind experiment. All right, so if your results are really, really large, you see something that happened and it's really, really big, that's what we call statistically significant. That's what we're looking for. We're looking for data or information or results that are showing some significant difference between the two groups, that we can say that the treatment did have an effect or the treatment did help. All right, so next we have what we call blocking. You can block if you think there's a difference ahead of time. For instance, if I was doing a study and I was looking at ethnicities of students, I can look at African Americans, I can look at Caucasians, Hispanics, whatever. But if I know there's a known difference between those subgroups already, I want to block for those differences ahead of time. So basically, I want to separate the groups by ethnicity before I even start the experiment. All right, and last thing we have is our matched pairs design. A matched pairs design is oftentimes where you have the same person getting both treatments. So like 1 week you get treatment 1 week you get treatment 2. It's a type of blocked experiment in which we match the same pair of experimental units together. All right, so again, if I give you aspirin, the real aspirin 1 week, and see how that affects you, and then the next week I give you no aspirin, but you think you're getting it, and if I measure how that affects you, then that's what we call matched pairs, because you're getting both types of treatments. And that's it.